So let's talk about AI. It's no longer just a concept from a sci-fi film. It's here, and it's quietly embedding itself into almost every piece of technology we use daily. Think about it for a second. Your smartphone's camera uses AI to make your photos look crisper and more vibrant. Your favorite music streaming service uses it to guess what song you'll want to hear next. It's in the smart assistant that sets your morning alarm and in the navigation app that helps you dodge traffic on your way to college. It's become this invisible yet incredibly powerful layer of intelligence that makes our digital lives smoother, faster, and more personalized. The tech is evolving at a breakneck pace, and its capabilities are expanding into areas that, until recently, felt exclusively human. For a long time, the creative and logical process of writing computer code was seen as one of those uniquely human skills. It's a craft that requires deep thinking, problem solving, and a precise understanding of complex languages. You have to be able to break down a big idea into thousands of tiny logical steps that a computer can follow. It's part art, part science. But now, AI is stepping into this arena. It's learning to understand programming languages just like it learned to understand human languages like English or Spanish. This isn't just about spell checking your code. This is about AI actively participating in the creation of software, apps, and websites. It's a huge leap forward, and it's happening right now. This shift is what we're here to break down. The idea of a computer program writing another computer program sounds a bit like a paradox, something out of a mind-bending movie plot. But the reality is much more grounded and, frankly, much more interesting. We're talking about a tool that could fundamentally change how we build the digital world. It could lower the barrier to entry for aspiring developers, supercharge the productivity of seasoned professionals, and unlock new possibilities for innovation that we haven't even thought of yet. This isn't just a minor update. It's a potential paradigm shift in one of the most important industries on the planet. So, the big question is, what does this actually mean for us? For students thinking about a career in tech, for businesses trying to build the next big thing, and even for everyday users of technology. This isn't a simple story of good or bad. Like any powerful new technology, it's complicated. It brings a whole host of incredible opportunities alongside some very real challenges that we need to think about seriously. In this deep dive, we're going to look at the whole picture, how it works, what it can do, where it might go wrong, and how you can prepare for a future where you might be coding alongside an AI partner. Let's get into it. All right, let's pull back the curtain on this. Autonomous code generation sounds incredibly complex, but the core idea is simpler than you might think. Imagine you're trying to bake a cake for the first time. You have a recipe book filled with thousands of recipes. Instead of reading one recipe and following it step by step, imagine you could just tell the recipe book, I want a vegan chocolate cake that's not too sweet and has a raspberry filling. The book, being incredibly smart, instantly scans all the chocolate cake, vegan, and raspberry recipes it has ever seen and writes a brand new custom recipe just for you. That's essentially what AI code generators do, but for software. These AI models have been trained on a colossal amount of existing code. I'm talking about billions of lines of code from public repositories all over the internet, like GitHub. They have read more code than any human ever could in 1,000 lifetimes. Through this process, they don't just memorize solutions, they learn the patterns, the syntax, the logic, and the common ways developers solve certain problems. They learn what a for loop looks like in Python, how to build a login button in JavaScript, and how to connect to a database in C++. It's pattern recognition on a massive scale. So when you give it a prompt, it's making a highly educated guess about the code that will achieve your goal. Think of it like predictive text on your phone, but on a whole different level. Your phone suggests the next word based on what you've typed and what it has learned from millions of other people's sentences. An AI code generator does the same, but for entire blocks of code. You might start typing a comment that says, function, to calculate the average of a list of numbers, and before you can even start writing the code yourself, the AI pops up with a perfectly formed function that does exactly that. It anticipated your needs based on the context you provided, and the vast library of examples it has in its digital brain. So to be clear, this isn't magic. It's not a sentient being that understands code in the way a human does. It's a very sophisticated statistical tool. It's a master of probability, predicting the most likely sequence of code characters that should come next based on the input it received. It's incredibly powerful because the dataset it learned from is so vast that its predictions are often astonishingly accurate. but it's crucial to remember that it's a predictive machine, not a thinking one. This distinction is key to understanding both its incredible capabilities and its inherent limitations, which we'll get into later. For now, just know that it's about learning from the past to build for the future. So, what's the big deal? Why is everyone so excited about this? The first and most obvious benefit is speed. Pure, unadulterated speed. Writing code can involve a lot of repetitive boilerplate tasks. Think about setting up a new project, writing the same basic functions for every new app, or just looking up syntax you've forgotten. It's the digital equivalent of chopping vegetables before you can start cooking. AI code generators can handle a huge chunk of this prep work for you. They can write entire functions, set up file structures, and generate test cases in seconds. This frees up human developers to focus on the more interesting, creative, and challenging parts of a project, the architectural design, the user experience, and the core logic that makes an application unique. Next up is accessibility. Learning to code has always had a pretty steep learning curve. It can be intimidating for beginners who get stuck on a frustrating bug for hours, not knowing where to turn. AI assistants can act as a personal tutor that's available 24/7. Imagine being able to ask your code editor in plain English, "How do I center this image on the page?" and getting an instant code snippet and explanation. This could dramatically lower the barrier to entry, allowing people from non-technical backgrounds to experiment with building software. It could empower artists to build their own interactive portfolios or scientists to write scripts to analyze their own data without needing to become expert programmers first. This leads to a boost in creativity and innovation. When you remove the tedious parts of a process, you create more mental space for new ideas. If a developer can build a prototype for a new app idea in an afternoon instead of a week, they're more likely to experiment and take risks. This rapid iteration cycle means more ideas can be tested, refined, or discarded quickly. Think about a student in a hackathon. With an AI partner, their small team could potentially build something far more ambitious and polished in a single weekend than was ever possible before. The AI handles the grunt work, while the humans provide the vision, the creativity, and the direction. Finally, this technology has huge potential in education and professional development. For students, it's a powerful learning aid. You can ask an AI to refactor your messy code into a cleaner, more efficient version, and then study the differences to learn best practices. You can ask it to explain a complex algorithm in simple terms. For experienced developers, it's a tool for continuous learning. If you need to work with a new programming language or framework you've never used before, the AI can act as your guide, providing examples and helping you get up to speed much faster than digging through documentation alone. It's a tool that can grow with you, from your first line of code to your most complex professional project. This isn't just a futuristic theory. These tools are already out there and being used by millions of developers every single day. The most well-known example is probably GitHub Copilot. It's built right into popular code editors like Visual Studio Code, and it works exactly as we've described. As you type, it suggests entire lines or even whole blocks of code. It's powered by an OpenAI model and was trained on all the public code on GitHub. Developers use it to speed up their workflow, a bit like having a very knowledgeable pair programmer sitting next to you, constantly offering suggestions. You can write a comment describing what you want to do, and Copilot will often generate the exact code needed to do it. Then you have tools like ChatGPT, which people might know more as a conversational AI, but it's surprisingly capable at writing and debugging code. You can paste a chunk of code that isn't working and ask, "Why am I getting this error?" It will often analyze the code, spot the mistake, and suggest a fix. You can also ask it to generate code from scratch. For instance, you could prompt it with, "Write a Python script that downloads all the images from a web page," and it will produce a working script in seconds. This is incredibly useful for quick prototypes, small utility scripts, or for learning how to approach a new kind of problem. Beyond these big names, there are more specialized AI tools emerging all the time. There are platforms like Replit, which have built-in AI features designed to make it easier for beginners to learn and build. Their Ghostwriter feature can help you complete your code, transform it, or explain it. There are also tools focused on specific tasks, like AI-powered testing platforms that can automatically generate tests to check your code for bugs. This saves developers countless hours of writing repetitive test cases and helps ensure the final software is more reliable and robust. These tools are becoming an integral part of the modern developer's toolkit. The impact is already measurable. Many developers report significant productivity gains, saying that these tools help them stay in a state of flow by reducing the number of times they have to switch contexts to look something up on Google or Stack Overflow. A student working on a final year project can use these tools to build a more complex and feature-rich application than they could have managed on their own. A small startup with limited resources can move faster and compete with larger companies. These real-world examples show that AI code generation is not a gimmick. It's a practical and powerful technology that is already reshaping how we build software. Okay, so we've talked about the impressive upsides, but with any tech this powerful, there's always a flip side. It's not a perfect system, and it comes with some significant challenges that we need to be aware of. The first and most immediate issue is the problem of errors, or what the AI community calls hallucinations. Because the AI is a predictive model, it doesn't actually the code it writes. It's just generating what it thinks is the most statistically likely solution. Sometimes, this results in code that looks plausible and correct at a glance, but is subtly broken, inefficient, or contains security flaws. It's like a student who has memorized formulas for a maths exam, but doesn't understand the concepts. They might get the answer right, but they can't tell you why. This leads to a new kind of challenge for developers. The task shifts from just writing code to carefully reviewing and verifying AI-generated code. You can't just blindly trust what the AI gives you. You still need to have the fundamental knowledge to be able to spot these errors. A junior developer who relies too heavily on AI might end up shipping buggy code without even realizing it. This also raises questions about debugging. When code written by an AI doesn't work, it can sometimes be harder to fix because the logic it used might be unconventional or unnecessarily complex, making it difficult for a human to untangle. Then there's the issue of intellectual property and licensing. These AI models were trained on vast amounts of publicly available code from the internet, but publicly available doesn't always mean free to use for any purpose. Some of that code was released under specific open source licenses that require attribution or have other restrictions. There's an ongoing debate about whether the code generated by an AI is a derivative work. Could a company accidentally incorporate code into their proprietary software that legally requires them to make their own code open source? The legal and ethical frameworks are still catching up to the technology, creating a gray area that businesses and developers need to navigate carefully. Finally, there's the risk of over-reliance and skill atrophy. If future developers grow up learning to code with an AI assistant always holding their hand, will they develop the same deep problem-solving skills and foundational knowledge as previous generations? It's similar to the concern that relying on calculators might weaken mental arithmetic skills. While these tools are fantastic for productivity, there's a danger that they could become a crutch. An effective developer needs to understand the why behind the code, not just the what. Striking the right balance between using AI as a helpful tool and ensuring developers still build robust, fundamental skills is a challenge that educators and the industry as a whole will have to address. This is the big one. It's the question on everyone's mind whenever a new form of automation comes along. Will this technology take my job? It's a valid concern, and the honest answer is, it's complicated. The role of a programmer is almost certainly going to change, but that doesn't necessarily mean mass replacement. History has shown us that technology tends to transform jobs rather than eliminate them entirely. When calculators became common, the job of an accountant didn't disappear, it evolved. Accountants started spending less time on manual arithmetic and more time on financial analysis, strategy, and advising clients. A similar shift is likely to happen in software development. Think about what a developer actually does all day. A surprising amount of their time isn't spent just typing code. It's spent understanding a client's needs, designing system architecture, collaborating with a team, debugging complex problems, and making high-level strategic decisions. These are all things that require critical thinking, creativity, and human-to-human communication, skills where AI currently falls short. The AI is a fantastic tool for generating a specific function, but it can't sit in a meeting and understand the nuanced business requirements for a new feature. It can't design a complex, scalable cloud infrastructure from scratch with future maintenance in mind. So instead of replacement, it's more useful to think in terms of augmentation. The developers who will thrive in the future are the ones who learn to leverage AI as a powerful partner. They will be the ones who can use AI to automate the mundane parts of their job, allowing them to be more productive and focus on higher value tasks. The demand may shift away from entry-level roles that primarily involve writing simple, repetitive code. Instead, there will be a greater emphasis on skills like system design, project management, quality assurance, and prompt engineering, the art of crafting the right instructions to get the best results from an AI. Of course, this transition won't be seamless for everyone. Some roles might be more affected than others. For example, jobs that are heavily focused on front-end web development using standard templates or simple scripting might be more easily automated. This means that continuous learning will be more important than ever. Developers will need to adapt, learn how to use these new AI tools effectively, and focus on building skills that are complementary to what AI can do. The job of a programmer might evolve into something more like an AI-assisted problem solver or a technical solutions architect. The title might change, but the need for smart people who can build and maintain the digital world will remain. When we start automating the creation of software, we have to talk about security. Software vulnerabilities are a massive problem, costing companies billions and exposing the private data of millions of people. Now we're introducing a new element into this equation, AI code generators. As we've discussed, these AIs can make mistakes. Sometimes these mistakes are just harmless bugs, but other times the AI can inadvertently write code with serious security flaws. For example, it might generate code for a login form that is susceptible to a common hacking technique like SQL injection, simply because it was trained on older, insecure examples from the internet. This brings up a huge question of accountability. If an AI generates insecure code, and that code ends up in a final product that gets hacked, who is responsible? Is it the developer who accepted the AI's suggestion without properly vetting it? Is it the company that employed the developer and encouraged the use of AI tools to boost productivity? Or is it the company that built and trained the AI model in the first place? These are thorny legal and ethical questions that we don't have clear answers for yet. As these tools become more widespread, we will need to establish clear standards and regulations for their use in professional software development. There's also a more malicious possibility. What if bad actors intentionally try to poison the AI's training data? Imagine someone flooding public code repositories with examples that contain subtle, hidden backdoors. If the AI learns from this poisoned data, it could start suggesting that insecure code to unsuspecting developers all over the world. This could turn a tool designed for productivity into a massive security threat, spreading vulnerabilities on an unprecedented scale. Securing the AI models themselves and the data they are trained on is a critical challenge for the companies building this technology. It's a new frontier for cybersecurity. For now, the responsibility falls squarely on the human in the loop. The developer is the final gatekeeper. This reinforces the idea that AI is a co-pilot, not the pilot. Developers need to be trained not only in how to write code, but also in how to read and audit code for security vulnerabilities, especially code that they didn't write themselves. Companies need to implement rigorous code review processes and automated security scanning to catch these issues before they make it into a live product. The convenience of AI cannot come at the cost of security. We need to be vigilant and treat AI-generated code with a healthy dose of professional skepticism. So, if you're a student looking at this changing landscape, you might be wondering what you should do to prepare. The key is not to fear the technology, but to learn how to work it. The first and most important thing is to focus on building a strong foundation. Don't let the AI become a crutch that prevents you from learning the fundamentals. Make sure you understand the core concepts of computer science, data structures, algorithms, and programming logic. These are the building blocks that will allow you to understand the AI's suggestions work, and more importantly, when they are wrong. Write code from scratch first, struggle with the problems, and only then use the AI as a tool to improve or speed up your work. Secondly, start playing with these tools now. Sign up for GitHub Copilot, experiment with ChatGPT's code generation capabilities, and explore other AI coding assistants. The best way to understand the strengths and weaknesses of any tool is to use it. Learn how to write effective prompts. This skill, often called prompt engineering, is becoming incredibly valuable. It's the art and science of communicating your intent to the AI in a way that gets you the best possible result. Treat it like learning a new kind of programming language. one where you're communicating in plain English, but with the same need for precision and clarity. Beyond the technical skills, it's crucial to double down on the uniquely human skills that AI can't replicate. Focus on developing your creativity, your critical thinking, and your collaboration abilities. Learn how to break down large, ambiguous problems into smaller, manageable parts. Practice communicating complex technical ideas to non-technical people. These are the skills that will make you an invaluable part of any team. The developer of the future won't just be a coder, they will be a problem solver, a designer, a communicator, and a project leader who uses AI as one of many tools in their arsenal. Finally, cultivate a mindset of lifelong learning. The pace of change in technology is only getting faster. The tools and programming languages that are popular today might be obsolete in 5 or 10 years. The most successful people in this field will be the ones who are curious, adaptable, and always willing to learn something new. See AI not as a threat, but as an opportunity to learn faster and build bigger things. Embrace it as a partner that can help you push the boundaries of what's possible. The future doesn't belong to the AI, it belongs to the people who know how to use it. So, after this deep dive, what's the final verdict on autonomous code generation? It's clear that this isn't just a passing trend. This is a fundamental shift in how we interact with computers and how we create software. It's a technology that is brimming with potential to make development faster, more accessible, and more innovative. It has the power to lower the barrier for new creators and to act as a powerful force multiplier for experienced professionals, freeing them from tedious work and allowing them to focus on solving bigger, more interesting problems. The opportunities for learning, creation, and productivity are immense, and we're only just scratching the surface of what's possible. At the same time, we have to approach this future with our eyes wide open. The challenges are just as real as the opportunities. We have to be mindful of the risks of errors, the potential for job market disruption, and the critical security and ethical questions that arise when we start automating creative and logical tasks. Blindly adopting this technology without putting the right guardrails in place would be reckless. The key will be to find the right balance, to harness the power of AI without abdicating our own responsibility and intelligence. The human developer must remain the pilot, using the AI as a trusted and capable co-pilot, but always keeping their hands on the controls. For students and anyone interested in technology, this is an incredibly exciting time. You're entering a field at a moment of profound transformation. Your generation will be the one to define the best practices for collaborating with AI. You will be the ones to figure out how to integrate these tools into your workflows in a way that enhances, rather than diminishes, human skill and creativity. The challenge is to remain curious, to ask critical questions, and to never stop learning. Don't just learn how to code, learn how to think, how to design, and how to solve problems in a world where the answer to "how do I write this code" is always just a keystroke away. Ultimately, the rise of AI in coding shouldn't be seen as the end of human programming. Instead, it should be seen as the beginning of a new chapter. It's a tool that can augment our own abilities, just as the word processor augmented the writer and the calculator augmented the mathematician. By taking care of the tedious and the repetitive, AI can free us up to be more ambitious, more creative, and more human. It's a future where technology doesn't replace our ingenuity, but amplifies it, allowing us to build a digital world that is more powerful, more accessible, and more amazing than ever before. The future is being coded, and for the first time, we have a new kind of partner to help us write it. If you learned something new, like the video, share your thoughts in comment section, and don't forget to subscribe the channel for more related videos.